welcome back, little geologists. We're on our last set of notes over the properties of a mineral and how we identify them. So let's wrap them up. Here we go. So next we're going to talk about crystal structure. So crystal structure, we're not going to touch a whole lot about it because you're not going to use it a lot. Like you don't use it out in the field. It's something you can only see really when you're in like a lab, and you're not going to do any labs over crystal structure, but we are going to read about it. So, crystal structure. The atoms that make up a mineral line up in a regular pattern. This pattern repeats over and over. The repeating pattern of a mineral's atoms forms a mineral's crystal structure. All of the crystals of a mineral have the same crystal structure. Scientists can use crystal structure to identify very small mineral samples. For example, scientists can bounce a powerful beam of particles off very small crystals. Because the atoms that make up minerals line up in a regular pattern, these beams produce distinct patterns of light. Shown in Figure 7, different minerals have crystals that are shaped differently. Halite crystals are cubic. That means they're in a cube. That is, they are shaped like a cube. You can break a large piece of halite into smaller pieces. Geologists classify crystals by the number of faces or sides on the crystal. They also measure the angles at which the faces meet. So there are examples here. You see halite, you can kind of see, I'll zoom in a little bit, maybe you can see it better. It has like, you can see the little cubes in the halite. That's what they were talking about, it being cubal. Whereas quartz is these long, kind of cylinder, hexagon, wait, 1, 2, 3, 4, 5, 6. Hexagon, yeah. 6, like they have a hexagonal shape. They have 6 sides. So that's what quartz looks like. So, we're going to go back to our notes. And number 6 is crystal structure. And I'm just going to put, scientists can identify a mineral by, let's go back to our notes. And it said, they can classify crystals by the number of faces or sides on a crystal. But we'll put classify instead of identify. A mineral by the number of sides / faces on the crystal and the angles at which the faces meet. Just so we kind of have it in the back of our mind. It's not super important right now for us because we don't do any labs over it. We don't really mess with it, but it's important to know. So let's move on to the next one. Cleavage and fracture. So this one's a little bit more difficult, so it's important that we know the difference between what cleavage and fracture are, because you will be using this. So, cleavage and fracture. You may be familiar with how the mineral mica can split apart to form flat sheets. So you see right here, this is the mineral mica, and it forms flat sheets. A mineral that splits easily along flat surfaces has the property of cleavage. So, in my notes, I'm just going to write cleavage and fracture, because that's a way that we can identify a mineral. And then cleavage is, my notes over here, property of a mineral. Oh, let's not put that. Let's actually go back to the reading. Change my mind. Can splits easily along flat surfaces. Splits easily along flat surfaces. That's cleavage. Whether a mineral has cleavage depends on how the atoms in the crystal are arranged. The way atoms are arranged in mica allows it to split easily in one direction. Figure 8 shows cleavage in mica. Most minerals do not split apart evenly. Instead, they have a characteristic type of fracture. Fracture describes how a mineral looks when it breaks apart in an irregular way. For example, when quartz breaks, it produces curved, shell-like surfaces. So I think we need to add under cleavage an example of an element. An example of an element that has cleavage is mica, because it splits along the flat surface. So the next word is fracture. And fracture describes how a mineral looks when it breaks apart in an irregular way. And their example was quartz. It says quartz breaks, when it breaks it produces a curved shell-like surfaces. So there we have cleavage. It splits apart easily along flat surfaces. And then we have fracture that describes how a mineral looks when it splits apart in an irregular way. And our example is quartz. So what you'll do for this is you'll actually fill out a graphic organizer. It's located on the front table by the smartboard. You'll fill this out and you'll fill out the definition, and then you're going to give me 3 examples of elements that have either cleavage or fracture. So you won't really, and when you use this in future labs, Mrs. Schaefer or I will break it apart. We'll break it apart for you, that way you're not breaking any elements and making a mess. So let's move on to the last one. Special properties. Special properties. Some minerals can be identified by special physical properties. Calcite bends light to produce double images, as shown in Figure 9. Other minerals conduct electricity, glow when placed under ultraviolet light, or are magnetic. So, for the last one, number 8, I'm going to put special properties. And then I'm going to put examples. Let's see, it said that calcite bends light to produce a double image. And what else did it say? And then I'm going to put other minerals. I forgot already. Conduct electricity, glow when placed under ultraviolet light. So we'll put other minerals can conduct electricity, glow when placed under an ultraviolet, violet or violet? It's not violet, it's violet. Can you imagine a violet light? Placed under an ultraviolet light, or are magnetic. Now the cool thing for you guys is you guys are going to get the chance to actually see this a little bit in the lab that you do next after these video notes. But I'll show you an example of what some of the minerals look like. So this is Mineralogy for Kids, and it's kind of a cool website. It shows you different things, like it talks to you about hardness, streak, color. But the one we're focused on the most is fluorescent materials. So this is what happens when you place a mineral under ultraviolet light. So like here's an example. This is what it looks like regularly. And then when you place it under ultraviolet light, it glows. Same with this one here. Before, after. Before, after. So So these are kind of cool just to play around with. You can kind of see how they glow. These are just a few examples. This one's kind of cool. And you'll get a chance to see a few of these. Not all of them, but a few of them. Well, that's it for the video notes. So good luck on your lab, and make sure you do your graphic organizer, and I'll see you on the flip side.